I'll just resume my stop. Okay, so we are on Amazon Redshifts part 2, and in part 1 we have seen what is Redshift, how it is architected, and some other details about Redshift we have seen, okay, like the sorting and uh, table distribution style, those things we have seen. Now we will see more details or more features about Redshift. Okay, so in Redshift we actually have this parameter group, and this is a group where we actually can say it defines some configurations about your databases or Redshift configurations, you can say. So basically we define some date format style and some commands and some configurations we define here. And the most important configuration here is workload management. Okay, and by default, actually, this is a kind of an admin activity, but and by default, we no need to change parameter group settings. Once my Redshift cluster is actually on, I'm going to show you. But you know, it is something that we should not change. That is what recommended by Amazon Redshift's official documentation, and they say it is configured for the best performance from the Redshift side. But just in case, if we look to change it for very specific requirement that we might have in our project, we can go ahead and create a new parameter group. So basically, default one we cannot go ahead and change. We might only create new parameter group and use that parameter group. Okay, so that is what about parameter group, something admin related activity which also should not be changed, but just letting you know, so it might be helpful if you give some interviews or if you somebody asks these questions. So again repeating, no need to change parameter group. This is what recommended by Redshift documentation, but just in case if it is required, you can go ahead and change it. I'm going to show you what kind of parameters that we have there. Then we have workload management in Redshift. So this is something, okay, if I give you an example, so what happens? Sometimes we schedule our query or some queries are so complex and they work on very huge data set. So this can cause, long running time of the queries. Okay, so now let's say you have 10 such queries which are running for almost 4 to 5 hours of time. Okay, so in this case, we might take help of workload management in Redshift. So what is going to happen? Let's say you have 10 queries which are running for a very huge and long time. So, and then you want to submit a query. Okay, a query means a SQL query, and then you want to submit a SQL query that is very critical, and that might have finished in few seconds or few minutes only, but it got stuck behind the queue because you already have 10 very huge long running queries already executing on the Redshift cluster. So in this case, we might take help from workload management in Redshift. So what we can do, so let's say we have 100% capacity with our Redshift cluster. Let us, some compute capacity we have and that is I mean, whatever it is, but it's 100% is there. So if we face such scenarios where our short queries are getting stuck behind the long running queries, we can create different uh, query groups or user groups, or basically we can do workload management. So we can create a group and allocate 70% of resources to that group, and in that group we can say, okay, my all long running queries or my all complex query which takes hours of time are going to be executed in that particular group. Okay, and my short queries, which are fast running queries, which do not take hours of time, they might just get finished in seconds or minutes, and they are very critical to us. So for those queries, I can use that remaining 30% of the total capacity. Okay, this is how workload management works in Redshift, and workload management is also a part of your parameter group in Redshift. So ideally, again, here also we should not change and create the workload management until unless in until unless we see a very specific requirement. So if I give you some example, I have some data set in my current project which has around 1 billion records. Okay, and for that data set also, if I execute some query, that gets finished in 15 to 20 minutes. Okay, so Redshift compute wise is a very powerful tool, but still, in case like if you have such such huge queries which might take hours, we should go ahead and change the parameter group. Basically, we have to add the parameter group and then create the WLM user groups, or we might create a query group. I'm going to show you this how to do it practically also. And just remember, this is not a developer or data engineer thing. Okay, it is more related to the guys who work or look job as a Redshift admin. Okay, and just in case if somebody asks you this question in interviews, so they might say that I have some short queries and they just get behind the queues, and it's not allowing me to execute that query, and that is a very critical query for me. I want the result as soon as possible. If they create such kind of story, you have to say we can use WLM in Redshift to handle this issue. So just let me see if my cluster is ready. Meanwhile, if you have any questions, you can ask me.
So for Redshift, the number one competitor is this one, Snowflake, right?
Yes, you can say Snowflake is a competitor. Azure Synapse is one of the competitor. Google's BigQuery is one of the competitor.
Okay.
Yes, any more questions? Okay, let's just see if it is available. Okay, it might take a few more minutes, but I want to continue only after I show you the parameter group and workload management, because it will not make any sense if I just move ahead. Okay, so maybe actually let me just move ahead. Okay, again, this feature called vacuum in Redshift. This is basically again kind of a admin related work, but again we should know it. Okay, and since 2018, Redshift has automated this process of vacuum. So first of all, this vacuum is a process of reshorting the rows and reclaim the space in a specified table or all the tables in current database. Okay. This means if I come to my data set here, okay, so what happens in Redshift? Let's say you ingested, ingested some these records on day one of your load. Okay, so basically these records are going to be sorted. They are going to be in a particular order which you have defined at the time of table creation. Okay, but next day, let's say you insert few more records. Let's say you insert these 10 more records. Again, these 10 or 11 records, whatever I've selected, they are going to be in a sorted order. But this complete record from row number 1 to row number 41 are not going to be sorted. Okay, so this piece of data from above of 29 row number and this piece of data 29 to 40, they are going to be sorted in their own respective, but they are not going to be sorted completely. And same way, if I fire a delete query, okay, I say delete from table where region ID is 10 or whatever. Like say I delete some rows from my table. Then also Redshift is going to mark my rows for deletion. Okay, it's going to archive those records and it's going to mark them for deletion, but it's actually not going to delete those rows. It's actually not going to claim back the space. Okay, so let's say I have 100 GB of data free today and I deleted 1 GB of data. So it does not mean that I will have 101 GB of data available in Redshift. And that is going to be available once Redshift performs vacuum. Okay, once Redshift performs vacuum, only in that case, these records are going to be sorted and these records are going to claim back the space from Redshift storage. So basically vacuum is the process of making sure the complete data in Redshift is sorted and complete rows which are deleted from Redshift, their space has been claimed back. Okay, so earlier this was a kind of a activity which we had to perform maybe every week, every 15 days or every month, depending on our project and our need. But now what Redshift has done, they have made this process automated. Okay, so whenever Redshift sees by default is actually 95%, whenever Redshift finds that 95% of its rows are not sorted, okay, in that case it's going to perform the resorting of the rows, and whenever it sees it has more than 95%, like more than 6% or 7% of data that is being deleted but its space is not reclaimed back, then it's going to reclaim back that space. Okay, so this is what vacuum is in Redshift. Again, it's a kind of admin activity. Now admins also no need to perform it manually, but if you have very specific requirements and you want to handle these things manually from your end, you can go ahead and use a manual vacuum process also. But again, I'm teaching you this thing because we should know these things when we go in interviews and when we write on our CV that we know Redshift. Okay, now we have 5 types of vacuum styles basically. So as you can see by their name, first 3, full means both sorting and your deletion, like your data claim is going to happen in a full vacuum. If you say short only vacuum, then it's like only the rows are going to be sorted. If you have any deleted data, that space is not going to be claimed back. And if you have delete only, that means it's only going to keep get the space back and it's not going to sort the rows. Then we have reach cluster. That means it's not going to completely sort the table, but it's just going to make sure that you achieve your threshold percentage by sorting some portion of your table. Okay, that is unsorted for now. Then in reindex, we have we have learned about the interleaved short keys. So those short keys actually it's going to short all those short keys when we say reindex. So this is 5 types of vacuum, and vacuum process, if you go ahead and do manually, it's basically some queries that you have to fire. And if I show you those example, you can actually watch it all. Um, okay, and if you see some examples here, this is what vacuum looks like. If you say vacuum, all the databases are like all the tables inside your databases are going to be reshot and reclaimed because you are just saying vacuum. And if you say vacuum and then table name, this means this particular table only is going to be, shorted and claim back the space. Then we can also define the percentage, like what percentage of data you want to be shorted and claim back. So you can say vacuum sales to 100%, and it's going to 100% reshort your row. If you say 90%, 80%, that is also fine as per your requirement. You can do it. Then we have vacuum short only sales to 75%. Like this is the example of short only vacuum. So you can go ahead and fire these queries. But again, I'm repeating, if you go through these things theoretically, that is more than enough. You don't need to practice these things because nowadays Redshift performs vacuum automatically. You don't need to do anything from your side. Okay, so if you have any questions about the vacuum process. Okay, I mean, if you have the question, please think about it.
No, Jalal, I'm good.
Okay, then let's see how parameter groups look like. So if you just go inside your cluster and just open this, and then on left hand menu, you have this option of configuration, I think. Yes, configurations. Then you have workload management, and if you go inside this, so basically I have created one parameter group. So let me just delete this. So I'll going to create a new one to show it to you. So by default, this is what you're going to get. Okay, by default, this is what you're going to get, a default.refshift 1.0, and it is a universal name. We all are going to have the same name. Okay, then if you come down, these are the parameters. Like we have two tabs here, workload management and parameters, and then we have parameters only. Okay, these are the parameters. So right now in default parameter group, it is not allowed to, you know, change these things. Okay, you cannot change these things. So auto analyze means your Redshift is going to analyze its table in databases automatically, and it's going to perform vacuum and some other activities by default. So if you just make it to false, then you actually are going back to manual vacuum process. Then date style, one of the example, you have ISO and month data in Y format, the default one. And if you want to enable case sensitive identifier, it's currently false. That means your queries is going to be case insensitive. Like this, you have some other parameters also. You have some query groups, required SSL, search path, and some other parameters. You no need to memorize these parameters. You should understand what is this parameter group and how it works. And again, repeating, we no need to change this until unless it is a very specific requirement for us. So it's actually easy. So as I mentioned that you cannot go ahead and change this parameter group, neither the parameters you can change or nor the workload management you can change. So if you see, we just have one default queue and its memory percentage is auto. That means how much resource or memory percentage the particular query needs. Automatically at a runtime time, it's going to decide and it's going to execute that query. Okay, and every query has the same priority. That means query priority is normal here. Okay, so if you want to create a workload, sorry, yeah. So if you want to create some parameter groups, you just simply have to create, click on create, give some name, maybe you can call it demo or something. And some description you have to provide here. And then you can go ahead and use this parameter group. And if you see parameters also I can change, I can click on edit parameters. I can convert into this one into false. I can convert this into some other date style. I can convert this into true, and all those settings I can change. So basically some database configurations we can change from this parameter group. Okay. And if you just do not touch this, and if you just cancel this, and then if you see right now, my workload management is to automatic WLM. That means every query is going to have the same priority, and they are going to have 100% of resources available. Okay, but if I just say switch WLM mode, and then if you see added workload queues, so I can go ahead and create these queues. Let's say I assign, like I name it Q1, or I name it large query. I can assign it 70% of resources, and how many queries I want to run concurrently. I can say 10. Okay, and if you want to scale this resource group automatically, if you want to do that, you can say auto. And if you also want to define timeout, then you can define the timeout. That means if I say this means after 1 lakh milliseconds, it's going to be query is going to be ended anyhow. Okay, so this is kind of optional, and if you want, you can define this. Then you have a user group and query group. Two parts are there. So basically, you can create a user group in which you can add humans like me, you, and some other persons. Okay, those guys who run very long running queries frequently, I can create a user group for those. Okay, and those guys, whenever they run the query, those queries are going to be scheduled on this particular query group. Okay, or this particular queue, I should say this particular queue, those queries are going to come here. Then same way I can create a query group, and at the runtime, okay, at the runtime maybe I'm saying select star and all those subjoins and all those query groups, sorry, groups and joins, or all those filters I can make there. And I can also say I want to run this query on this particular query group. So based on that, it's going to take this particular queue to be executed. Okay, and then you can save this, and if you come back again here, you can just edit workload queues, and we can add a one more queue. And same way, this, let's see, the q2 is created, we can call it short queue, and 30% of resources we can assign here. Concurrency we can define, timeout we can define, and then we can define the user group or query group. Okay, and then it's going to perform the fast queries here. Anyhow, you can actually create any number of separation. You can create multiple queues, and you can define these queries to be executed there on these queues. But again, I am repeating, uh, these kind of queues should not be created until unless you have very specific requirement. Okay, so normally, like in my project also, like I have worked on 2 or 3 projects, nobody uses this WLM. Okay, but when you have some very huge data sets, when you have TBs of data, and you have very complex queries, and you also want to run your short queries, in those cases only you should use these sort of settings. So yes, if you have any more questions. So am I being very clear here, or you guys have no questions at all? Any questions, any scenarios that you can think of?
Jalas, I think on later uh, classes, we are going to see how that data is processing from the S3 to Redshift through Glue, right? We are going to discuss later classes.
Yes, yes, that is in
Oh,
the project. So yes,
okay,
yes, that's in the project. And I have given you the example how we can use copy command to load data from S3 to
right.
Redshift. So
Okay,
basically,
instead of using Glue, we can do copy into. Okay,
exactly, actually, same command you can execute from the glue. So
got it.
basically, pass the
Okay.
credentials, like which Redshift cluster you want to execute, what are the credentials, and
Mhm.
then you can connect and you can execute those copy commands from glue code.
Okay. Okay.
Okay, if you have no questions, then I'm simply going to move ahead, and later on, if you find some questions, definitely you can come back to me, okay? Then this is very simple one. So whenever you want to delete complete data from a table, so instead of saying delete, we should say truncate. So truncate actually does not require any vacuum. And as and when you perform that query, truncate, and its syntax is truncate table name. So as and when you perform the query, it's going to be deleted the data and also claiming vector space. Delete is not going to claim vector space even if you do delete star from table. It will wait for the vacuum to happen and then only it's going to claim back the space. Okay, then we have encoding in Redshift. Encoding means for every column that we have in our Redshift table. Okay, so basically every column that we define in our create table statement. Okay, we can go ahead and compress that column specifically. So no need to define compression on table level. We can define compression on column level. Okay, this is what encoding is in Redshift. Encode auto is by default for the table. So if you guys do not define a table, okay, and then encode auto is going to be executed and some generic encoding is going to be applied on all the columns. So if I just do it, I'm not sure whether it will happen or not. If I just come back to my query editor, connect to database. So we do have the sales data 2 table here. And if I just run this command, then this is the query. Okay, then this is the query. And if you remember, I had executed this command to create this table. Okay, and here I have not defined any encoding or anything else. But if you see this command on Notepad, Okay, and if I just make it more readable for you, then this is what I get when I do show table on Redshift. Okay, you can see my create table has encode for every column. Okay, you can see my index column is a character variant. That means it's a varchar character. Okay, and it has already assigned a encoding type for this. So you can see I have L0 encoding here, and for all the character varying columns, it has default applied L0 encoding, and it has also decided the distribution style to be auto. Okay, so this is how a Redshift actual Redshift query looks like. So if I see, this is the same query, this create table sales data download, and this query is same query. Okay, only difference here is that Redshift has auto applied the distribution style, and it has also applied encoding style. Okay, and if you see here, that for some of the columns, it has already defined some basic encoding types. So for our short keys, whenever we define the short keys in the table, we should not encode that particular column. So basically it says assign raw compression, and raw compression, it means no encoding should be assigned for your short key. So whenever you use compound short key or interleaved short key, we should not define those columns in encoding. Okay, and whenever we define boolean, real, double precision, these kind of data types, we should again use raw compression. Okay, and then whenever we use small int, integers, big int, decimal, that means some numerical data types, timestamp. Okay, we should use AG64. And like also in this table, if we had any small int or big int column, we would have got the show table command and with encoding as AG64 for all your numeric columns. Okay. And then for char and varchar, the by default one is L0, that is it is going to use. So whether we define the encoding on table label or not, it's going to have that encoding applied to its columns automatically. Okay. And these encoding types, okay, this EZ64 and LZO are some kind of algorithms which makes sure while storing the data on any memory, it is taking almost null or not null. It is taking very less space. Okay, so if we apply AG64 for your integers or numeric columns, it is going to make sure that the data amount of data that we need to store that information is as much as less as possible. Same way for varchar or character type of columns, we are going to have LZO kind of compression techniques. Okay. So this is what encoding in Redshift, and I have few more example of encoding, some specific encoding examples. So Redshift has many more encoding examples. So we have mostly 8 LZO, AZ64 are like LZO and AZ64 are the most used one. Then we also have some byte encoding, delta encoding, and mostly it and few more encoding types. So again, no need to memorize these encoding types. You should only understand what is the concept here, what we are trying to achieve with the encodings. So we are trying to achieve that our table take less space, okay, or we should say as much as less space while we are storing data into that table. So for that, we should define some encoding types for each and every column. If we don't define, then Redshift is automatically going to use default one. So yes, if you have any questions on encoding types. Any questions here?
No questions, Julius.
Okay, so I hope you guys are understanding what I'm trying to say. Okay,
Yeah, all
so
data structures. Yeah.
come again, please.
Yeah, just yeah, understood all the data types and conversions.
And again, I'm repeating, no need to memorize. Maybe you can memorize this AZ64 for numeric columns and L0 for your varchar, but
Okay.
no need to memorize all the encoding types.
Right.
Okay, so some specific encoding examples are byte dict encoding. Okay, so whenever we have distinct values in our column, those are less than 300 or 400 like that, or this is what Redshift says. Okay, so whenever we have less distinct values in any particular table's column, in that case we can use byte dict encoding. So how does it work? So as you can see, let's say my data set has country column. Okay, so obviously I may not have more than two, or like whatever the country names that we have in this whole world. I think around 230 or 235, whatever it is. Let's assume 250 for now. So we have 250 unique values in that particular country column of any table. So we, instead of using L0, even though it is a character type, instead of using L0, we could use byte encoding. So what's going to happen here? Let's say I define some length of this column. So maybe what I can do here, I can define something like this. Let's say I have category column and I can say varchar 30, because 30 is the least amount of number that I might need to store all the country names, because some countries might have some big names. Okay, so then so let's say we have made the fixed width of that particular column to 30 bytes of information. So now instead of storing all the 30 bytes, or instead of occupying all the 30 bytes, what it's going to do, it's going to assign some numbers to those unique values. So for the England, it's going to assign 0. For America, it's going to assign 1, and like that it's going to assign. So you can see from, and for the to storing these compressed value, okay, to store this compressed value, it might not need 30 bytes of information, it might only need 1 byte of information. Okay, so we are reducing our storage capacity from 30 bytes of fixed length to 1 byte of compressed data using byte dict encoding. Okay, so again repeating, for when we have very less unique values in our table for any particular column, we can use byte dict encoding. How does it work? It assigns a number to those unique values and stores that number only. It does not store the original value. It just stores the number and the reference to that. So it might also store 0, and somewhere in memory it will also store that 0 belongs to England. Okay, so whenever we run the query, we are not going to scan this 30 byte of information. We are going to scan this 1 byte of information. And when the query results come back to us on console, we are going to see decompressed data. That is, this information we are going to see. We are not going to see this information. This information of compressed value is only going to be stored. It is not going to be represented to you. Okay. So if you have any questions in this byte dict encoding, okay.
So this compressed value is like what is stored in database, right?
Yes,
Memory,
yes.
right?
Yes. So whenever you're going to do file select query, you are not going to get the compressed value. You are going to get the original value.
The new size byte is what?
It is like you have defined this much at the create table statement, but it is going to use this column to store its information on Redshift storage.
The compressed value is the storage, right?
Yes, yes. Storage is with the compressed value. So on your left hand side, the two columns are representing the actual data, and on your right hand side, the compressed values are there. What is actually going to be stored on the Redshift?
The, the difference between the compressed value and new size, what is that? It's in bytes and it is in like.
No, no, no. See. This original data value, like see, this England got converted into this compressed value of 0.
Yeah, got it. Yeah.
Okay. So to store England, you needed 30 bytes of information. Okay. Okay. And to store England in this compressed value format of 0, we only need 1 byte of information. So
Okay.
when we needed 30 bytes, instead of that, now we only need 1 byte of information. So we are saving 29 bytes every row.
Okay.
Okay. And just to let you know, we should not use byte encoding for columns which have more than 500 or like that unique values. It is not supposed to be optimized for that. Okay, so instead of optimizing data storage capacity, you might go ahead and de-optimize that. So these byte,
500 byte?
come again, please.
How much byte you mentioned? 500.
No, I am saying, let's say you have a column. If I just show you this, no, not this is not the good example. So let's say if I have this kind of table, okay, and I have this NB hood full column, okay, and this might have more than 1,000 unique values, or maybe more than that. It might have 10,000 or 1 lakhs also. So for such kind of columns, we should not use byte encoding. We should use LZO only. So only the columns where you have very less unique values, only in few hundreds, okay, then only should use byte encoding. Okay, and then we have delta encoding. So if I again come back on here, so you can see. So let's say for use cases, whenever we have continuous or increasing or decreasing numerical or timestamp column, okay, so maybe we might have date, we might have numeric column. So for example, I have this numerical column which might be primary keys or something else, which is which is a kind of increasing in a sequential way. Okay, so we can use delta encoding here. Okay, so this is my original data in column A. This is my original data. It is like 10,001, 10,002, 10,003. Okay, and let's say to store this information, I needed 4 bytes. If I don't compress this, I might need it 4 bytes of information to store this data. But if I apply delta encoding, okay, if I apply delta encoding, so my first row is going to be stored as it is. Okay, and then on next rows, it's going to store only the difference from the next rows, different from the previous rows. Okay, so it's going to store 10,001, then it's like plus 1 is 10,002, plus 2 is plus this. So it's like that it's going to use. And to store this data, we might again need 1 byte of information. So for the first row, we will need 4 bytes, all 4 bytes, because we are storing the complete value here. But for the next of the few rows, we might only need to store delta. That means difference between the column values, and we will be using less amount of size. So the Redshift example here is, this is the one which we have. So let's say we have 5, then it's like original size would have been 4 bytes, but difference is again going to be 4 bytes, and it's going to store compressed value of 4 in a 1 byte of information. Okay. It's actually starting from the 1. I have not captured it completely. So the First one is going to be stored in the original format. Then third row is 50. Then we have difference of 45 between this row and this row, and it's only going to store the compressed value, and it's only going to take 1 byte of information. And whenever the values change in opposite direction, like here we have 200 and then it reduce, then we might have to store -15, and it will also store 1 byte of information plus 4 byte of information for flags. Okay, so this is how it works. So again, here, whenever we have sequential numerical date timestamp columns which are increasing or decreasing in sequential manner, we can use delta encoding. Okay, but if we have too much of variance, like we have 50, 200, then we have minus value, then we have upper value. So it is not idealized, it is not optimized for such scenarios. So we should have a sequential proper columns only, not changing in order. So if you see, like here I was storing 4 bytes of information, but here I will need 1 plus 4 bytes of information. And if in every row this is getting changed, then instead of storing 4 bytes of information, I will be storing 5 bytes of information in every row. So we should avoid to use delta encoding whenever we have plus minus kind of scenarios. Whenever we have sequential ordering of any column, that is numerical, date or timestamp, we can use delta encoding. And again, I'm repeating, no need to memorize these coding. You should understand this, like what is the use case of encoding and what is the default encoding, and that encoding can be applied on column level in Redshift, and it helps you to reduce the disk space needed to store that data in table. Okay, few examples I have given you of byte encoding and delta encoding. If you can understand this and if you can memorize this, it is great. But again, no need to waste your time on these things. Just understand and move ahead. So yes, if you have any questions. Any questions? Okay, I mean, if you have no questions, we can wrap up this class. And I'm going to show you one quick example of Redshift, some little bit hands-ons and some other features tomorrow.